All right, so we are wrapping up chapter 7 this week. Next week, we're starting with 7.3 this week, where we're going to talk about 3 new sets of formulas. Today, we're going to talk about double angle formulas. When I see you tomorrow, we're going to talk about reduction formulas that take the exponent on a trig function, like sine squared or sine to the 4th, and bring it down by 1. So I can take a sine squared into a sine, or a sine cubed into a sine squared. And then on Wednesday, we'll talk about the half-angle formula, and then do a small group activity where you get some practice with those formulas and solving problems with them. Yeah? Friday, we're going to start talking about trig equations and how to solve trig equations, and that is most of next week. That'll take us up to spring break. We get back from spring break, we have a couple days of review, and then our second midterm. All right, so for today, I'm going to pop the equations up. We're going to copy them down. We're going to talk about where they come from, and we're going to do some examples. Sound good? Yes, okay, nodding is good. Thank you. All right, so start with the formulas. Like everything else we've done in this unit, we get 1 for sine, 1 for cos, 1 for tan. We'll start with sine. So sine of 2 times an angle theta, 2 theta instead of 1 theta, which is how it gets its name, double angle, is equal to 2 sine theta cos theta. Yes. It is 2 times theta. It is 2 times theta. Sine of 2 times theta is equal to 2 times sine of theta times cos of theta. Which is nice because we know we can look up sine of theta and cos of theta on our unit circle if we need exact answers. Yeah. So again, one of the goals of this is taking something that's not on the unit circle, rewriting it in terms of something that is, so we can find an exact answer. Cos actually has 3 related formulas. So we're going to start with the first one, and then we're going to leave a blank space for the other 2 and come back to them. So cos's formula is cos squared theta minus sine squared theta. Or we're going to come back to those ors in a minute. And then we get the tangent one, tan of a double angle, tan of 2 theta, is a fraction. We get 2 times tan theta on top. And we get 1 minus tan squared theta on bottom. Bless you. And we're going to answer a question before we fill in those other 2 blanks for cosine. The big question is, where the heck do those formulas come from? And I am hoping that the structure of some of those looks a little familiar, as they are in fact related to stuff we already have in our toolbox. So we're going to derive one of those equations because the process for figuring out the other 2 is identical to the process for the first guy. So we're going to start with sine. Yeah. So I have sine of 2 times theta. And I want to rewrite that into something more familiar. And at some point in your math journey, you learned that multiplication is shorthand for repeated addition. X plus x is 2x. X plus x is 3x, right? The number in front tells me how many of those things I added together. So if I have 2 theta, that's telling me I must have added 2 thetas together, theta plus theta. So I can rewrite this as sine of theta plus theta. Does that expression look vaguely familiar? Does it match up with anything we've seen recently? Yeah, sine A plus B. The only difference is now A and B are the same angle. It's sine of A plus A, or theta plus theta. So we're going to use the sine addition formula. So the sine addition formula says sine of the first, I'm going to have to scooch you over here a little bit, times cos of the second, plus sine of the second times cos of the first. Except now the first and the second are the same angle, theta and theta. I don't have A and B, I have theta and theta. Which means I now have sine times cos plus sine times cos. Which means I have 2 sine cos. 2 of them added together. Our double angle formulas are just coming from those sum formulas we learned in 7.2. They're not new, they're just simplified for the special case where the 2 angles we're adding are identical. A and B, now we have A and A, or theta and theta. Yeah? The formulas for cosine and tangent come from the same place. I'm going to scooch you back over. Remember that the formula for cosine of A plus B is cos cos minus sine sine. Well, cos theta times cos theta is cos squared theta. Sine theta times sine theta is just sine squared theta. So this is cosine's addition formula simplified. This guy, similar idea. We know that tangent's formula is tan A tan B. Yeah? Tan A plus tan B. Well, tan A and tan B are the same. Tan theta plus tan theta is 2 tan theta. In the bottom, it was 1 minus tan A times tan B. But now it's 1 minus tan theta times tan theta squared. They're just the sum formula. We just made angles A and B the same. Yeah? We get 2 extra formulas for cosine because way back in like January, one of the first relationships we learned about trig functions was the Pythagorean identity. Sine squared plus cos squared equals 1. We got it by looking at a triangle in the unit circle. Yeah? So I can use the Pythagorean identity to rewrite cosine's rule so it just has cosine. I can replace sine with the Pythagorean identity. Or I can rewrite it with just sines. I can replace the cos. So if we replace the cos, we end up with 1, oops, that's not what I meant to do, 1 minus 2 sine squared theta if I replace the cos instead, I end up with, or rather if I replace the sine instead, I end up with 2 cos squared minus 1. Yay. reminder that I do not expect that you have those memorized. They're stuck in my head because I've been doing this a long time. You just have to know how to use them. Yeah. Okay, we're going to do one, maybe two examples, depending on how much time we have. Yeah. Questions before we do an example? Are we still conscious? I'm a little worried today. Let's do an example. So if tan theta equals -3/4, so we know tangent of an angle, and we know that that angle is in the second quadrant, we want to find sine of 2 theta and cos of 2 theta. And that should freak us out a little bit because we don't know what theta is. I don't know what theta is. How am I supposed to find sine of 2 theta? So we're going to use two different tools. The first tool is we're going to use what we know about SOHCAHTOA and right triangles to find sine theta and cos theta. If I can build a right triangle, I can find sine and cos if I have tan. Yeah. Once I know sine theta, cos theta, I can use the double angle formulas to figure out sine of 2 theta and cos of 2 theta. So a two-step problem. First is figuring out sine theta. Next is figuring out sine of 2 theta. Yeah. My recommendation when you see problems like this where they give you, instead of theta, they give you tangent of theta, sine of theta, cos of theta, draw a picture for the right triangle that's represented by that fraction, by that trig fraction. Yeah. So that's the very first thing I'm going to do is I'm going to draw a picture. I know that I am in quadrant 2. So I am living over here because they told me theta is in quadrant 2. I know points in quadrant 2 have a negative x and a positive y. I also know that tangent is sine over cos. And for ordered pairs on the unit circle, sine is my y, cos is my x. So they have given me the x and y coordinates of my point. Y is 3, 1, 2, 3. X is 4, 1, 2, 3, 4. I'm sitting right here. Positive 3, negative 4. That's what gives me tan of -3/4. Yeah. And I'm going to draw a right triangle. I'm going to drop a line down here. If this is 3, this is also 3. So I have the two legs of the triangle, horizontal and vertical leg. I need the hypotenuse. How can I figure out the hypotenuse if I know the legs? Not SOHCAHTOA. Starts with a P. Pythagoras, Pythagorean theorem. Yeah. Yeah, we know Pythagoras told us, I'm going to do it down here, that a squared plus b squared equals c squared, where a and b are the legs. We know the legs, 3 and 4. We're just going to plug those legs in. So a squared is 3 squared. B is minus 4 squared. C squared. And we do the math. 3 squared is 9. And negative 4 times negative 4 is positive 16. And 9 plus 16 is 25. Yeah? And how do I undo a square? I don't want c squared, I want c. Square root, perfect. Both sides, square root both sides. Square root, c is 5. Perfect. I can go back in my triangle and write that. I know my hypotenuse is 5. I know when I draw my angle for a triangle in the coordinate plane, it's always with respect to the x-axis. So this is the angle of reference, angle of interest. And now I want to build my sine and cosine fractions. So now we go to SOHCAHTOA. Sine theta is opposite over hypotenuse. In that triangle, if I start here, opposite side is 3. Hypotenuse is 5. Perfect. Yeah. Same thing for cos. Yeah. Cos theta is adjacent over hypotenuse. What's the length of the adjacent side? Negative 4. Very good. Negative 4. Hypotenuse is 5. Cosine is negative in quadrant 2. Yeah. Good. Perfect. SOHCAHTOA Pythagorean theorem. Yeah. Like math 2 trig. Seen it before. Nice and comfy. And now we take the nice comfy math 2 trig and we marry it to the fancy pre-cal trig by using the double angle formulas. I don't want sine theta, I want sine of 2 theta. So you go up to the top of your page and you pull from your trig toolbox. Sine of 2 theta is 2 sine theta cos theta. I know sine and cos are both fractions, so I'm going to have 2 times a fraction times a fraction. I'm just going to pull the fractions for the appropriate trig functions. What was sine theta equal to? 3 over 5. What was cosine theta equal to? Minus 4 over 5. Write the formula, plug in the numbers. Yeah. It's a multiplication problem. If we were feeling super lazy, we could grab our calculator. I want to be fancy and do it by hand. I know I can make whole numbers fractions by putting them over 1. I know when I multiply fractions, multiply across the top to get the new numerator, multiply across the bottom to get the new denominator. So across the top, 2 times 3 times negative 4. What is 2 times 3 times negative 4? Negative 24. Yes, very good. Negative 24. On the bottom, I have 1 times 5 times 5 is 25. Happy face. Yeah. Perfect. All right, next one. They asked us to do sine of 2 theta. They also asked us to do cos of 2 theta. We can use any of the 3 double angle formulas for cos. I'm going to use the first because I know 1 minus 2 sine theta is going to give me whole number minus fraction, which is gross. Cos squared minus sine squared is fraction minus fraction, which is less gross. So the first double angle formula for cosine is cos squared minus sine squared. And we know what cos and sine are. We're just going to take them and square them. So fraction squared minus fraction squared. Sub in the appropriate fractions. Cos is minus 4 over 5. Sine is 3 over 5. A reminder that when we square fractions, we square everything in the fraction, numerator and denominator. So negative 4 times negative 4 is 16. 5 times 5 is 25. And then minus 3 squared is 9. 5 squared is 25. And 16 minus 9 is? I'm so glad we're right awake today. Last time I checked, it was 7. Please check my math. It's been a long day. I'm pretty sure it's 7. Yeah. Again, process is mostly old math. We know how to build a right triangle. We know how to use Pythagorean theorem to find a hypotenuse. We know how to use SOHCAHTOA to set up a trig ratio. Now it's taking those trig ratios and using them with a double angle formula. Yeah. I have a question for you. They asked us for sine of 2 theta and cosine of 2 theta. What if they asked us for tan of 2 theta? How could we find tan of 2 theta? There are a couple of answers, at least 3 that I can think of. Maybe 2. But there's a couple. There's multiple. I'm going to give you like a minute in your small groups. Discuss. How would you tackle that? Given what we know about the system, how would you find tan of 2 theta? You should talk to each other. I might call on your table to answer. How would we find tan of 2 theta? Organizing our binder is good. Not at the expense of not taking notes, yeah? It's such a deep sigh. 9 more minutes left. You can hang in there. And then it's only like 9 days until break. Yes. I hear at least one idea. Ideas? There's nothing on that paper that would tell you, there you go, that's a good start. Yeah, that's one way to do it. What's the other way? How do we define tangent? Ooh. Okay. Two ways to do this. We're going to do them both. I'm going to call on Omar. Omar, what was your suggestion to find tan of 2 theta? Very good. And we know what tan theta is. That was given in the problem, -3/4. So we could take this formula and just substitute in what we already know about the system. 1 minus -3/4 squared. You can see we get some ugly fraction math going on. So looking at the numerator, 2 goes into 4. That's going to leave me with a 1 and a 2. When I square this guy, 3 squared is 9. 4 squared is 16. So that's going to give me -3/2, 1 minus 9/16. I'm going to rewrite 1 as 16/16. What is 16 minus 9? 7. Yeah. So we have -3/2 over 7/16. When we divide fractions, we multiply by the reciprocal. Keep the numerator, flip the denominator. So keep numerator times flip the denominator. I don't know why I got 2 of those there. Oh, it looks very weird to me. I don't like that. Yeah. I was reducing because this is basically 2/1. So I have a 2 in the numerator, a 4 in the denominator. I divide numerator and denominator by 2. I get 1 and 2. Reducing. I see some reducing that can happen at this stage. 2 and 16 are both divisible by 2. So that becomes a 1. 16 divided by 2 is 8. And then we multiply across the top. What's 3 times 8? 24, so -24. 1 times 7 is 7. That was a lot of fraction math. Nobody likes fraction math. If we already know sine of 2 theta and cosine of 2 theta, what's the definition for tangent? The very first one we learned. Sine over cos. Yeah. We can bypass the double angle formula here. Yeah, there is a shortcut because I already have those 2. I can go straight to a fraction that doesn't involve any subtraction or addition. What was our double angle for sine? -24/25? 24/20, what was, yeah? Perfect, so numerator is -24/25. Denominator cosine was 7/25. Yeah. Dividing fractions, multiply by the reciprocal. Keep the numerator, -24/25. Flip the denominator. Ooh. Yeah, those 25s just completely cancel, and I get directly to -24/7 with a lot less fraction math. Yeah. We did that because this is an important reminder. We're learning new tools every day, right? Our toolbox for trig is getting bigger and bigger. We're not throwing out the old tools when we learn new ones. A lot of these problems are going to have more than one path to a right answer. So if you see a shortcut, try it. Worst case is it doesn't work, you have to go back to the long method. But it's worth exploring, right? Your homework this week is in the textbook. The links are in Canvas. I didn't see anything in Delta Math that was really good practice with these formulas. You've got enough to get started on it. We'll pick up tomorrow with a warm-up and then our reduction formulas. Yeah.